Hello everyone, in today's video we are going to cover section 9.2, Introduction to Circles. After studying this section, you'll be able to begin solving problems involving circles. First, we'll look at circumference and area of a circle. Example 1, we want to find the circumference and the area of circle O. Remember, circumference we can think of as the circle's perimeter, and the area is the space the circle encompasses. The circumference formula is equal to circumference is equal to pi times diameter, and then the area formula is equal to pi times the radius squared. Now, if we look at my circle to the right, I have a radius of 7 inches. So the diameters are chords that go through the center of the circle, would be 14 inches total because it's 2 radii of 7 inches. So my circumference would then be pi times 14, or 14 pi. Now, if I was keeping it in exact terms, I'd leave it as 14 pi. I could also simplify it and multiply by, say, 3.14. which would give me about 43.98 inches. Now the area is pi r squared, so that's equal to 7 squared times pi. 7 squared is 49, so 49 pi. Again, if I was going to simplify this and leave it non-exact, it'd be about 153.94 square inches. Next, we'll look at arcs of a circle. We can think of arcs of a circle as a portion of the circle's circumference. An arc is made up of 2 points on a circle, and all the points of the circle needed to connect those 2 points by a single path. So in my figure to the right, I have arc CD, which is the blue portion of the figure, symbolized with this symbol here, a little arc sign over CD. Now, when we talk about arcs, we can talk about either their measure or their length. Now, the measure of an arc is equivalent to the number of degrees it occupies. So if the whole circle is 360 degrees, whatever fraction of the circle the arc is, we'd multiply that by 360 to find the measure of the arc. Now, length of an arc is a fraction of the circle's circumference, so it's expressed in linear units such as feet, centimeters, or inches. Looking at example 2, we want to find the measure and the length of arc AB. So arc AB is this portion of the circle here. Now, if I want to find the measure, that's the number of degrees that this arc encompasses of the entire circle. The entire circle is 360 degrees, so I want to figure out how much this arc is of the entire circle. Now, I can clearly see that points A and B lie on the Y and X axes. So this whole arc encompasses the first quadrant, making it 1/4 of the entire circle. So if it's 1/4 of 360 degrees, then this arc length is 90 degrees. Now, if I want to find the length of arc AB, that tells me the portion of the circle's circumference. Now, I can see that point B is 60 and A is 0.6, giving me a radius of 6. So remember, circumference was pi times diameter. So my diameter here is 12, so my circumference is 12 pi. Remember, this length was 1/4 of the entire circle. So 1/4 of 12 pi would give me a length of 3 pi. Now, if I keep this exact, I would just keep it as 3 pi. If I use 3.14, then it would be approximately 9.42 units. Next, looking at sectors of a circle. A sector of a circle is a region bounded by 2 radii in an arc of the circle. Now, the figure at the right shows us sector CAT of circle A, which is this portion of the circle here. I can see that the radii are AC and AT, and then the arc is CT. Now, arc CT has a 90-degree measure, making this sector 1/4 of the entire circle. So if I want to find the area of the sector, it's just the portion of the entire circle's area that we would have. So if this is 1/4 of the entire circle, now the area of the entire circle given a radius of 6 would be 36 pi. So I'd have 1/4 of 36 pi, which would be 9 pi. Now, if I wanted to approximate this, this would give me an approximate area of the sector as 28.27 inches squared. And lastly, looking at chords and inscribed angles of a circle. Now, a chord is a line segment joining 2 points that are on a circle. Now, we're very familiar with the diameter. The diameter is the longest chord of a circle. In my figure below, we can see that we have chords AB and chords AC. Now, chords AB and AC make up the inscribed angle, angle BAC. So an inscribed angle is an angle whose vertex is on the circle and whose sides are determined by 2 chords of the circle. Now, we can also say that angle BAC is said to intercept arc BC. So I can see that arc BC is this arc here, and then the endpoints of B and C are parts of my angle BAC. So an intercepted arc is an arc whose endpoints are on the sides of an angle and whose other points all lie within the angle. We'll learn later that inscribed angles are 1/2 the measure of the intercepted arc. Now looking at our sample problems, we have problem 4. Harry Health looked ahead to chapter 10 and discovered that the measure of an inscribed angle is half the measure of its intercepted arc. Use this information to find the measure of inscribed angle DEF. So I can see here that I have arc DF, which is 80 degrees, and I want to find the measure of inscribed angle DEF. Well, thanks to Harry, we know that the measure of angle DEF is going to be 1/2 the measure of the intercepted arc. Now I know that angle DEF intercepts arc DF because the endpoints D and F are part of angle DEF. So I know that the measure of angle DEF would be 1/2 of 80 degrees, which would be 40 degrees. So angle DEF will have a measure of 40 degrees. Next, looking at problem 5, if HJ is the diameter of circle O, what are the coordinates of point O? Now, since HJ is the diameter of circle O, that would mean point O is the center of the circle, making H and J both equidistant from O, or the middle point. Since O is the middle point between H and J, I can use the midpoint formula to find the coordinates of O. So remember midpoint formula, x1 plus x2 divided by 2, so I'd have -4 plus 8 divided by 2, and then y1 plus y2 divided by 2, so -3 plus 5 divided by 2. -4 plus 8 divided by 2 would give me a coordinate of 2, and then -3 plus 5 divided by 2 would be 1, so my center is at 2, 1. And lastly, looking at problem 6, show that triangle INS is a right triangle by A, finding the measure of angle INS, and B, finding the slopes of line IN and line NS. Now I can see that the measure of angle INS would be half of the intercepted arc because angle INS is an inscribed angle, and an inscribed angle is 1/2 the measure of the intercepted arc. I can see that it intercepts arc ICS, and I can see that arc ICS is 1/2 of the entire circle. So 1/2 of 180 would be 90 degrees, making this a right triangle because it has a measure of 90 degrees. Now, if I look at B, finding the slopes of line IN and line NS, if I have opposite reciprocal slopes, this would tell me that my lines are perpendicular. And if my lines are perpendicular, then I would have a right triangle. So if I find the slope of line IN, it would be 8 minus 0 over 6 plus 10, or 8 over 16, or 1/2. So the slope of line IN is 1/2, where the slope of line NS would be 8 minus 0, and then 6 minus 10, which would be 8 over -4, which would be -2. Now I can see that my slopes are opposite reciprocals, therefore making this a right triangle. In today's lesson, we learned circumference of a circle can be found with the formula circumference equals pi times diameter. Area of a circle can be found with the formula area equals pi times r squared. An arc of a circle is a portion of the circle's circumference. The measure of an arc is the number of degrees it occupies, and the length is a fraction of the circle's circumference. A sector of a circle is a portion of the circle's area. The area of a sector is equal to the fraction the sector encompasses multiplied by the circle's entire area, and an inscribed angle's vertex lies on the circle, and its two sides are two chords of the circle, and an inscribed angle is half the measure of its intercepted arc. That's a wrap on today's video. We'll see you in the next one.